Hey ladies and gentlemen, welcome to your calculus review sheet for your test, which is in a couple days. As you can see, I already have the definitions up for 1, 2, and 3. In 1, for a function to be continuous, it must have no breaks on its graph, and for every input you have exactly one output. For 2, the graph must approach the same point for both sides. Remember, infinity cannot be a limit. For it to exist, it has to be an actual numerical answer, other than infinity. Right? The vertical asymptote will exist if you have an undefined point in which, when you factor it down, it will be non-removable. That will give you a vertical asymptote. Okay, looking at number 4, you're going to do f of x. We're going to do the limit as we approach 0 here. You can see as we approach 0 from the left and the right, it hits here at -2. The second question down here for b, the screen's going to slide a little bit. Second here. So down here at B, I have to move this up. Okay, so this was -2. As we approach -1, okay, which would be here, we'll hit here, so this one's -3. You could also substitute that into the original function, which was up here. So I can also plug in -1 here, so this would be 1 plus 2 over -1, which would be -3. That's exactly what I had down at the bottom. So moving on to example 5. As we approach g of x for the x value from the positive side, looks like we are going to positive infinity from this side. So this limit will be positive infinity. I'm going to rewrite this function, 3x minus 2, so when I slide my screen down, I'll still have it on my screen. So for the top one there, we're going positive infinity. For the bottom one here, okay, so this one's going to positive infinity. As g of x approaches 0, we're right here at 0. So let's plug 0 in. 3 times 0, 0 minus 2. This is 0 over -2, which is 0. So this is good. Okay, so let's flip over to the back where we have a plethora of limit problems. Right. So starting with the first one, this is continuous, so I can just plug 2 in. So that'll be 10 minus 3. So our limit would go to 7. Okay, this is continuous at x equals 2. Okay, it would be undefined at, what would that be, 3/5, but we're not looking at 3/5. So let's plug our 2 in. 6 plus 5 on top, 10 minus 3 on the bottom. So we're looking at 11 over 7. All right, limit of 7 as x approaches 2. Well, that's constant, so that would be 7. Cosine of pi over 2. Pi over 2 is 90 degrees, and cosine is the x-coordinate at 90 degrees, which would be 0. Right. If we plug 3 in, notice this is undefined, so we need to figure out if it will have a limit or not. So if it's removable, which it is, we will have a limit here. So if you plug 3 in here, you're going to get 6 over 1. Your limit will be 6. Over here, okay, if you plug -2 in, you'll be undefined. That means we need to check if it's factorable. So the x plus 2's cancel out. So that would be removable. And now I plug -2 in here, I'll have 1 over -4. So 1/4, -1/4. All right. Moving up. All right, so we're down here at 12. This would be soap. Notice if you put -5 in here, this would be undefined. So we will do same. Opposite, which would be minus. This would be 5x plus 25 all over x plus 5. So that's removable, so therefore we'll have a limit. We'll have -5 squared minus 5 times -5 plus 25. So 75 is your limit. As far as sine of 2 pi over 3. So that would be 60, 120. So sine would be the y-coordinate, and that would be the long leg, which would be square root of 3 over 2, which would be positive in quadrant Okay, it looks like we're approaching 0 from the positive side of 1 over x cubed. So I'm thinking of this as 0.00001 cubed. So that's going to be a very, very small number over a large number, which will get a positive infinity. All right, if we plug -2 in, we get undefined. There are no numbers that multiply to be 2 and add up to 1, so I can't factor this. So we need to figure out, okay, we have a vertical asymptote at -2, but what's happening on the left side of -2? So I'm going to go ahead and plug in -2.0001 squared plus -2.0001 plus 1 over -2.001 plus 2. So this will be a very small negative number on bottom. Let's look on top. So if I square a negative, that's positive. So let's say that's positive 4 times 2. So that's about 8. This here, if I subtract these, I'll have -1. A little over -1. So either way, this is going to be a positive number on top divided by a negative number. So we're looking at negative infinity. Okay, so over here, again, I can't factor this out. This is non-removable, so I have a vertical asymptote again. So as I approach 1 from the right, I'm looking at 1.0001. 1.0001 minus 1. So up top, we'll have a larger positive number, around 0.999. This will give me about a positive 0.001. So this looks like a positive and a positive, so positive infinity. Over here, this is not factorable. And we're approaching 3. It looks from like the left side. I believe that's a negative. A second here. All right, so let's pick up with 17 here. Notice if I plug 3 in, it's not going to give me undefined. So I can just plug 3 minus 4 here over 3 squared plus 9, which is basically -1 over 9 plus 9, which is 18. So -118. Alrighty then. Okay, guys, let's pick up number 18. You're going to have to do a conjugate here. Remember, on the bottom, keep them separate. Okay, up top, this is going to be x minus 9 because the inner and outer. This is x. That's my outer, and that cancels out with this. So this one and this one cancel out. 3 squared of x minus 3 squared of x, bye-bye. And then you got your minus 9. This is going to be over x minus 9 times the square root of x plus 3. Notice I didn't FOIL on the bottom because I saw these will cancel out. I'll leave you with 1 over the square root of x plus 3. Now put in my 9. So that's the square root of 9, which is 3 plus 3. We're looking at 1/6. Okay, so cosecant, okay, is, I believe, 1 over sine. And then I'll have pi over 3. Okay, which is 60 degrees on a 60-degree angle. Remember, this is 1. This will be the square root of 3 over 2. So this would be 1 divided by the square root of 3 over 2. Keep a change of flipping. So 2 over the square root of 3. Multiply that radical 3 out of the denominator. I'm going to get 2 root 3 over 3. That's what cosecant pi over 3 would be. As far as this goes, we're getting 3 from the positive end. If I plug 3 in right now, I get undefined. So I'm going to have to go 3.01. This will be 3 minus 3.01. This will be 3.01 over a negative small number. So we're looking at negative infinity. All right, going down to the bottom here. Approaching 0. Well, that doesn't give me undefined, so we'll have 0 over 0, and that will be -1. So this limit would be 0 on the right. Tangent of x. So we got tan of 5 pi over 6, which would be sine 5 pi over 6 over cosine which of 5 pi over 6. So 30 times 50 is, 30 times 5 is 150. So I'm at 150 degrees. Okay, so that's 150 degrees. That leaves me 30 degrees here. So this would be my short, which would be a half, and then my long would be square root of 3 over 2. So sine of 5 pi over 6 would be a half. And I'm dividing that by the cosine of 5 over 6, which would be negative square root of 3 over 2. So I'm going to keep the half, change this to 2 over square root of 3. The 2's cancel out, leave you with negative 1 over the square root of 3. And then we're getting that radical 3 out of the bottom again. So this is negative radical 3 divided by 3. And that's 22. All right, going to 23. Notice I can factor that or can't I? This looks like x minus 1 times x minus 1 over x plus 1. So that's non-removable. So at negative 1, it looks like we're non-removable. We just got to figure out if it's going to infinity or negative infinity. So let's go ahead and put something on the positive side of negative 1 in here, which would be negative 0.999 minus 1. And this would be negative 0.999 minus 1 over negative 0.999 plus 1. So up top, we're going to get a negative number times a negative number, so this would be a positive number just shy of 4. Because this is like negative 2 and this is like negative 2. And negative 2 times negative 2 is positive 4. And down here, 1 minus 0.99 would be 0.001, which is positive. So we're looking at positive infinity for number 23. All right, we'll see you on the next page here in a second. Okay, we're on the third page now. We're going to discuss continuity. Let's start with this guy, and we'll do him in blue. So this is my top function. Okay, so when we have x is negative 1, we're looking at a y value of negative 4. Okay, let's go after the middle function left. Right. When we have x is negative 1, looks like we're looking at the negative 1 squared, which is 1. 1 plus 1 is 2. So clearly these don't line up together. Okay. Let's look at x is 2. So this is now my right side. If I put 2 in here, I'll get 5. And my bottom problem, I'll pick up the 2. So 2 cubed is 8. 8 plus 4 is 12. So neither of these match up. So is the function continuous? We are not continuous at x equals negative 1 because the y values jump. How many units? 6 units from negative 4 to 2. Okay? And let's go back to the other one. Also, we are discontinuous. I should say at here. We delete that. At discontinuous at x equals 2 because again the y values jump from 5 to 12. So that would be 7 units this time. Okay? And that's all you would have to do for 24. Alrighty. Picking up down here, we're going to find the a value that makes this continuous. So let's see where we left off at negative 4 on the top equation. So if I put negative 4 in there, looks like I'm going to get 7. Right? As far as the bottom equation, if I put negative 4 in there, I'm picking up at, well, negative 4 squared is 16, so we got 16a minus 16 plus 5. Now to be continuous, these y values would have to be the same. So I'm going to set this equal to this. That'll be 16a minus 11. So I'm going to add 11 over. I'm going to get 18, and then I'm going to divide by 16. So this is 9 over 8 for a. That's the value that will make it continuous. Okay? On the back. Now we're closing in on the end here. This is a great problem, guys. Right, let's start with the top left. So if I plug 1 in, I'm going to get 3a plus 4. My middle, left side, I need to put 1 in here. I'm going to get 2a plus b plus 1.